The level editor system is done. It only took me around about a week to get finished, so I'm pretty happy with the progress I've made. Obviously, I said before it'd probably take me around about a month, so knowing that it only took me a week is pretty good. Here's some examples of the things you can make with it. It's got a variable grid system. It's got everything. It's pretty cool if you ask me. You know, the way it works is that you have like a list of things on the side and you can place them down, obviously. You can shift click to place down multiple. You can make a new map, you know, the variable grid size, and you can export and import it, which is probably the proudest thing I've done on this is the import and export, because I think it works really well. But let me show you how I got here. I started off with this really basic grid system. All I wanted to do was just learn the very, very basics of Unity, like how game objects worked, how script works, and all of that. And I have to say it's really intuitive. If you see everything almost as a template, so a game object is just completely empty, and then the things you add to it are like the components, which I guess actually is exactly what they are. But if you see them more as like a factory builder in OOP or something like that, I think it makes more sense. Factory builder being where there's like multiple parts and it all come together to produce one thing. So yeah, once I kind of figured that out, yeah, I made the super basic grid system you're seeing in front of you here. All it does really is just generate an 8x8 grid with a bunch of game objects. Now, obviously, not the most impressive thing, but it did teach me the very basics. It was very useful to understand. With that being said, I did find out later that Unity actually has a tile map system, which apparently is a lot more efficient. And to be honest with you, I think it worked perfectly well. There's no need to like redo it. Unless it starts getting laggy. So like currently it can't handle maps over 100 by 100. But realistically, do I think that's going to be required to have a map over that size? I don't really think so. So then after that, I made a really basic ad system. So I just added these 3 template things, which is a ball dropper, a ball catcher, and a plain tile, which I'm just going to use to build around stuff. Really simple actually to add these. All I did was, luckily that Unity has this inbuilt thing, I think it's called on mouse button down or something, on button down, on mouse down maybe. I'll edit it into the video, and super useful. It basically detects if a mouse has clicked any type of collider. And the way I did it is I made this tiny little game object up here, which basically just stores what the player has clicked and resets it if they're not pressing shift. And obviously within the grid system on the button down, I just add it as a child, instantiate it, which apparently means like to create something, which is pretty useful. And I just make it as a child. Now I was reading that actually using components instead of children are better, but I kind of wanted to use children just because it feels more intuitive to later on add more complex stuff, such as, you know, maybe triggers, stuff affecting other things. It just to me, it feels more sense to have children, and I don't think it would decrease performance too much. So yeah, after that, I just added a really basic reset button. Now, I thought it would be basic, but it turns out that it wasn't basic at all. There was this whole entire IEnumerator, which is basically like a thread, which can be made and weighted or yielded. So once I understood that, it was really easy. You click it once, it goes red. And if you click it again within 5 seconds, it just deletes everything and creates a whole new grid, depending on whatever grid you started with. So then there was the big task, Fen notation export. Now, I'm not going to call it Fen from this point on. I'm going to call it BK exportation because I had to change quite a lot about it. So firstly, let me explain Fen notation. So Fen notation stands for Forsyth-Edwards notation. And basically what it is, it's a way to annotate a chessboard at any one given time. Now with Fen notation, you have the actual grid itself explaining it, and you also have the previous move, I believe. In the example above, provided by chess.com, great website, I'll check out, or Lichess if you're actually trying to get into competitive play. But anyway, I digress. Let's just take the top row here. Now it says R1BK3R. Now, if you don't understand what it is, it kind of just looks like jumble. But it's actually really simple. What it's saying is going from left to right, there's a rook, and then there's 1 blank space. There's a bishop, a king, then 3 blank spaces, and then another rook. Now with chess, obviously, it's always a fixed 8x8 grid. And obviously with my game, it's not going to be fixed. It could be up to 100 by 100. So I had to have a way to annotate that. So the way I've done it is that the first lot of letters before an underscore is the size of the map. So if you have a 100 size map, it'll be 100 and an underscore. If you have a 16 size map, it'll be 16 underscore. But for the example I'm going to show you, it'll be 10. Now the rest is actually very similar. Instead of using slashes, I used colons, I believe, which just made more sense to me. Whenever I see slashes in programming, I always think of files or folder structures, I should say. So I kind of wanted to stay away from them. From that point on, I had all these little things. So I think I've got B, capital B, and P at the moment, which is plain block, ball catcher and ball dropper. Now what it does is it figures out where they are and the spaces in between them exactly the same. So if I have this 10 by 10, there's 4 here, then there's a ball dropper, a ball catcher, and then a couple of plain blocks or something. I don't know. I'm reading this out now. I'm going to have to edit it in later. Hopefully that's what comes up. So when it exports it, it will look something like this at the bottom there. And basically what that is the code for that row. Very similar to Fen notation. Now the way I did this is it basically reads through all of the children. So it's a little bit inefficient. It's pretty quick either way. It's not multi-threaded or anything. I might do that in the future maybe, but it's still pretty quick. Minus for like 100 by 100, I think it takes about a couple of seconds to generate a code, which once again isn't the best, but for now it will do. I'm not too fussed about it right now. You know, we've got to actually make the game. So yeah, it makes this code and then you can put it back into the input and you can just load it, which is really cool. And even if you're on like a 10 by 10 grid and then you attempt to load a 100 by 100 grid, it will load completely fine, which is awesome. And I've got to say I'm pretty proud of this. It took a while though. So I just want to go over some of the issues I had because maybe, you know, you'll be doing something similar and you'll run into them. Shout out to this guy called Positive7. He is in the Unity developer community Discord, which I'll link down below. Absolutely amazing. He really helped me out because I was stuck on this issue for ages. Basically what the issue was is that when I was loading a new grid, for some reason it referenced the old grid and then generated a new one, even though I called deleting and then generating a new one in that order. So what I think was happening, and he helped me come to this conclusion, but my initial idea was maybe this was like atomic. Maybe Unity does functions in an atomic way. So when you call something, there's no intermediary state. It is all done at the exact same time, maybe in some cool multi-threaded way. I don't know. That's my guess. So I spoke to him and we talked through the problem. He showed me some really cool ways to debug in Unity, which are amazing. I'm definitely going to use them in the future. We eventually found out that that was the case. It was being done in an atomic way. Now, atomic in computing basically just means there's no intermediary state. So if I'm doing, I don't know, 1 + 1 + 1, there's not going to be a 2 anywhere in there. It's going to be immediately to 3, else it cancels, I think. It's a really bad explanation, but that's basically the idea. So what ended up happening is I just made an IEnumerator with his help, and I just delayed it by a couple of frames. So it just deletes it, waits a couple of frames, and then generates a new one, imports all of the stuff, nice and easy. And I did the same kind of thing for the creating of a new level. Here's just a little bit of showcase in the background where I go over what I want to do next time. Hopefully in the next devlog, I will have a few things down. I want to get the level loader done on the actual playable side. Also, while I'm reading this out, I realized that I haven't actually added a way for people to edit the inventories of players. So I'll probably do that as well. That will probably be the first thing I do actually before the next devlog. Yeah, I think that's the main thing. I just want to get the main level loading done, the inventory system done, and then maybe this very basic ball catcher and ball dropper done. Just so it's, you know, very nice and I can just do a very basic level playthrough, which means I'll probably have to add in wires. Now, wires, I've been thinking about this for quite a while. I think what I'm going to do is some type of linked list which generates on the world generation. That way you can actually have power flowing from one to another. Now, there is also the way that I could just check for its neighbors and then push out power, but I feel like that's way less efficient, I should say. But we'll see what ends up happening. It'll be interesting either way. Just the way of linked lists is that way I can have like a power generator area. And if you lose that, then all of them like turn off. Whereas with a grid kind of system, I'm worried you might actually be able to make infinite power because one wire will be like, hey, I've turned off. And then the other one will be like, oh, okay, I should turn off. But then before that can happen, the other one sees the other one on and it turns itself back on and it will be like a weird infinite loop, almost like a game of life kind of thing. So yeah, that's that devlog done. It's been a bit of a rant, admittingly, but I'm really quite proud of how far I've come in a week. Admittingly, I haven't had as much time as I wanted to work on it, but I think it's coming along pretty well. So yeah, thank you for watching. This is only the second episode on my channel, so if you enjoyed, please hit that subscribe, the like button, all of that. It really does help out. I think I got around about 60 views on my last video, so I'm pretty happy with that. So yeah, peace and love, guys. Have a good one. Bye-bye.